Hello, you're welcome back. All right, so we're gonna be looking at Venn diagrams, okay? So, of course, we already know that a Venn diagram is actually a diagram that illustrates the relationship between a universal set and its subset, okay? So now, uh, a Venn diagram is actually uh, drawn, okay? Using is drawn with we use rectangle shape, okay, to represent the entire universal set, the entire area of the universal set. They will now use circle to represent the subset in the universal set, okay. So now I'm starting with the Venn diagram of just two sets. And these are the Venn diagram of two sets. So I'm going to be shedding some region, okay. Then I will be writing the relationship or the set notation of such region. Now, as you can see, I have just two sets, set A and B. Of course, the two subsets, okay, just two subset A and B. And I've for this first diagram shaded the intersection between A and B. So this is A intersection B. Okay, so let me shade everything. Okay, here. The A and the B, or the circle. Of course, if I ask you, okay, what is the operation, the set operation that I've just said shaded? That is the union. This is going to be A union B. Now, what if I decide to not shade any of the circle, but I shade outside the circle? So, of course, you know that the two circle, if I shaded the two circle, that is the union of the two circle. Now, I'm outside the two circle, okay? Of course, that's the complement. So, this is actually A union B. It's going to be A union B, okay? A union B, then complement or complement. So the complement of A union B. All right, so now let's look at a situation where I shed cir- the circle of A, but I didn't include the point where A intersects with B. The point where I have both A and B is at this intersection, so I'll only shade A. So this is gonna be A. That's gonna be I just shaded the difference of the two states. That's A difference A intersection B. A difference A intersection B. And vice versa. I can also do that for in the other way around, okay? Where I will shade, let's say if this is B now, the A is B, if this is B, that was shaded, and this is A. Okay, so that's gonna be equal to the diagram is gonna be B, then minus A intersection B. All right, so these are basically the Venn diagram, right, for two sets. Now let's look at a situation where there are some word problems. Okay, let's look at a situation where you are being given that the number of an universal set, let's say in a class of 40 students. Okay, 40 are students and you are told that uh, uh, okay, 20 of them, 20 students actually offer art. So that's set A. Set A is art or offer, okay, account. 20 of them offer account, right? Then, of course, they now have 25 offers business studies. So 20 20 offers account while 25 offers business studies. All right, and you were told that 4 offers neither. Force offers neither of the two subjects. All right, so which simply means that there are just two subjects they can choose from: account or business studies. Okay, 4 offered neither. So now the question is, evaluate the number of students that actually offers both subjects. Question mark. So we can actually represent this information in a Venn diagram. Yes, we can, and it will be easy for us to actually. So in a Venn diagram, there are two sets, set A and set B. And of course, set B. So putting our values there, okay, so we are told that the entire of set A is 20. All right. So now if I want to get A only as A, the part that deals with A minus A intersection B. Okay. So the very first thing I'm gonna do is I don't know what the intersection is. That's what I'm looking for. So let me call that intersection. Okay. The intersection I'm looking for, let me call it X. Let me call that intersection I'm looking for X. So if the intersection is X, that means the intersection of A and B is X. So in that case, now to get A minus A intersection B, that means I'm subtracting the intersection. Okay, at this part of the circle, I'm subtracting the intersection from set A, and of course, the set A is 20. So that's gonna be 20 minus the intersection X. That is A only. Okay, A without the intersection. Let's do like we also do like for B only, B without the intersection. Okay, B is 25. Then without the intersection, I have to subtract the intersection, which of course is X. Okay, so this is A only, A and B, and of course B only. Please take note of that. Then we are also told that the complement of the entire set outside the set is 4. Okay, so since we are looking for X, you know what that means. The universal set, we are told from the question, the total number of persons in the class is 40. So you know very well that if I add all these subsets, it will actually yield the universal sets. Okay, that way I'll be able to make X this. I'll be able to find X. So that simply means that 20 minus X, that is A only, plus X, A and B, plus 25 minus X, which is of course B only, then plus 4, not A, not B, but outside the complement. Okay, everything yields 40. So I'll collect light times 20 plus 25 plus 4. That's gonna have, I'm gonna have 49 if I'm not mistaken. Yes, 49. Minus x plus s is 0. Then I have minus x left equal to 40. So of course, making x the subject. Okay, I take minus s to this side. That's going to be plus x. So this is going to be equal to, s is going to be equal to 49 minus 40, which is 9. So 9 students offers the both subject. Okay, 9 students offer both subjects. So Venn diagram, word problem that involve Venn diagram is just very easy. Okay, if you can actually represent that word problem, okay, in a Venn diagram, you'll be able to solve that word problem question. Okay, so this is just a typical illustration of a Venn diagram involving two subsets. Okay, so we're going to be looking at the Venn diagram of Venn diagram involving three subsets in the next video. All right, so see you in the next video. Thank you very much.